Good morning, everyone.
Good morning.
Hi, good morning.
Let's start it. So as we discussed yesterday, today we're going to see a few concepts of SQL first to understand what is a primary key, foreign key, and then we'll move on to Power BI. Okay. So I understand a few of you have joined directly in Power BI. So let me cover those SQL concepts. Right. How many of you are here completed the SQL here? If you could respond in the chat window, please. Okay. All right, okay. So this may be like a revision for you. Okay. So probably, just don't answer those questions because you know the answers already. Okay. So this is very much needed before we proceed to the data modeling. So that is the reason we'll be covering that. So as discussed yesterday, like the course contents I have already shown you. And why we need to, learn SQL is because if you want to get any data, one should have some idea about the SQL concepts. Okay. So that's the reason we are going to cover the SQL fundamentals. All right. There are two types of real-time systems. Okay. One is OLTP, the other one is OLAP. OLTP is for online transaction processing. OLTP is on oil. Okay, OLTP is online transaction processing. OLAP is online analytical processing. Okay, so two systems are needed. The reason being, one system is to manage the database modifications. The other system is to do the data retrieval for the data analysis purpose. Okay. So usually in the offices or in the real time, you hear this, data warehouse, got updated so that we can run the reports now, right? Something like that. So the reason being the two systems are there, right? So we spoke about just now, OLTP and OLAP. OLTP, this gets all the data basically from different applications. Something like this, a billing counter example, if you take, in the billing counter, there are different transactions, right? They take place. All the data is stored inside a OLTP system. Later, it will be copied or cloned, okay, into OLAP, online analytical processing. It is like your data warehouse. From multiple OLTPs, all the data will be gathered together. Let's take an example of a shopping mall that has branches across India. So each system has, or each state has one database. Okay. So if our CEO wants to see entire India, how are our sales? Okay. Then we need to combine all the databases data into one place, right? So that place you can call it as a data warehouse. There is a process to gather all the data from the different databases and put that inside the data warehouse. This process is ETL, extract, transform, load. Okay. All the data that is recorded inside the OLTPs with the help of ETL, extract, transform, load, that gets loaded into one OLAP. Okay. So this is for the transactions. This is the data retrieving and for the decision making. And OLTP is the original source of data because this is where the transactions they take place for the first time, and later the same data can be copied into OLAP. Okay, that's the reason OLAP, it gets the data from different OLTP databases. OLTPs are short, they have the short transactions. OLAP has long transactions. Simple example, if you take an ATM, it is OLTP because it is to manage the transactions and usually they are short. But if you take any analytical related thing, that usually takes more time and they are long transactions because of the complexity in the queries that we write. Simple example, your business wants to understand in the last 6 months in a particular region of a particular manager, right? How are the sales in FMCG? Okay, let's say a business is there in multiple segments and they want to understand a particular region and FMCG segment only, right, in the last 6 months. So the more number of where clauses and all we'll have to write on this one. So obviously it will take more time as you know, the queries are complex. Okay, what is normalization and integrity we will learn, you know, slowly. So understand the two types of systems. One is for the transactions management, one is for the decision making. Okay, so after looking at this OLTP and OLAP as a reporting analyst or a data analyst, okay, which system we interact with mostly, OLTP or OLAP? Maybe this is for the beginners. Only the Power BI ones who directly joined. After looking at this, what is your understanding as a data analyst or a reporting analyst? What is that we use the most? OLTP or OLAP? Okay, any answers, please? In both the places, we have the data. My question is, which one we use the most? Yeah, we use the OLAP because this is the data retrieval and decision data analysis system, right, for the decision making, right? So we usually get OLAP access, okay, as a data analyst. So there are data warehouses, we get the access to them, not to the full data warehouse. Entire data warehouse access is not usually given to the data analyst because our responsibilities, our role may be limited to only one particular department. Let's say if you are from finance, finance data you should be able to handle, then yes, you get a finance mart access. Okay, it's a data mart. Data mart is a subset of data warehouse. Okay, so data warehouse is a place, it's a central repository of all your business data. But one analyst is there who works for HR department, then HR data mart access will be given to that analyst because that analyst doesn't need to see other departments' data, right? So there are different concepts there, but remember what is a data warehouse, what is a data mart. These are few names that we need to remember as a data analyst. Okay. Fine then. So as we just understood that there are two types of systems and a couple of things are there, normalization and integrity. I'll come to that point shortly. Okay. As we understood that, we need to work with OLAP and all the data is located inside some database, be it a very big database like a data warehouse or one OLTP, but either of the cases, we need to use a common language there, SQL. That's the reason we always recommend everyone to learn SQL as well. But anyways, there are certain, things are needed before proceeding to Power BI. So let us talk about data normalization process. Okay, of course, this is part of SQL, but definitely, one should learn before understanding Power BI data modeling concepts. Let me show you one example here. Okay, take a look at this table. It's like a simple employee table. I hope all of you are coming from Excel background and please quickly answer these things. Use the chat window or you can unmute yourself to answer these questions, okay? So here's the one. You take a look at this data. Okay, this is your data table. So can we find out the total salary by the department name? Can we find out the total salary by the department name looking at this data? Can we answer this question? Is it possible?
Yes.
Okay, how is it possible?
By pivot table, by using pivot table.
Pivot values.
Correct. You can create a pivot table. You can create a pivot table. That's absolutely right. So using a pivot table, we can easily summarize this data. Perfect. And look at the same data and answer this. Can we create, can we get the total salary by the job? Is it possible? Can we do that? Total salary by the job. Do you see the job column there?
Yes.
Okay, so it is possible, right? So you have the job here and you have the salary here. Okay. So can we find out the salary who joined before 2021?
Yes, we can find out.
Right, that is also possible because you have the date of joining and the salary. Okay, great. So everything is possible with this single data set. Okay. Let me show you another example here. Take a look at this data. Tell me, can we get the total total salary by the department name? Is it possible?
No.
No, we can't. Why? Because department name is not there. That column is not there.
Correct. Yeah, the department name column is not there. So it's not possible to create that. Okay. Similarly, can we get the total salary by the job? So same thing, not possible because we don't have the job there. We have only the job ID. But where is that corresponding information? That is there in some other table. You see here on the right hand side. Okay. So if you want to get the sum of salary by the department name, you need to look at this department ID and fetch the department name from this table. What is the formula that we use? If I want to get the department name here.
VLOOKUP.
Yeah, lookup value is this, table array is this, is it, second column 0, and then we'll get the department names there. Right? Okay, perfect. Here we go. Same thing applicable for the job also, right? If I want to find out each and every job, their designations, if I want to find out the same thing, again, I need to write a VLOOKUP, right? So you know that already in Excel how to do this. The same thing in SQL, we do joins to get the data from different tables. But you should get a question here, right? The question is, why are we maintaining the data in multiple tables? Why not in a single table? Right? It's very easy to answer. There is something called data redundancy. Okay, what is data redundancy? Same values, are repeated multiple number of times like this. You see that manager, 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 but instead of writing manager for multiple number of times, you can assign the key, okay, like one here, one is manager, okay. So what is this data redundancy? If the same values are repeated for multiple number of times, we can call them the data is redundant. But instead of repeating those values, what is what we do? We just assign only those keys. And using those keys, you can fetch the corresponding value as and when, in the report if they are needed. Right? So what is the advantage of this? right? You may be thinking multiple tables are being created, right? Will the data size increase? No, not actually. Answer this, please. If I give you a pen and paper and I ask you to write one and I ask you to write manager, which one consumes more ink? Writing one consumes more ink or writing manager consumes more ink?
Manager.
Manager. So that means if you can assign a simple key to it, right, you can actually avoid writing the same value for multiple number of times. As a result, you can see a significant reduction in the space, right? So the data should always be normalized like this. Now let's try to understand what is normalization, right? So it's a denormalized table where all the data is located in one place and you can easily create the reports and you see everything in one place. But the problem with this denormalized data set is the size of the data. And moreover, indexing may not be possible. Nothing but to do the data retrieval quickly. That's not possible with the text values and all, right? And if you look at the normalized data like this, where you have multiple tables. So what is a normalization process? A table that will be split into multiple dimension tables and a fact tables. Okay, a table is the same data. This table, okay, we have split that into multiple dimension tables and fact tables. Okay, what is a dimension table? A dimension table that holds categorical data, something like location information, department information, designation information, right? So this kind of data that you see in the dimension tables, we also call them dim tables. So let's take a look at this. Here it's a dimension table because it has only the department related data. Here it is a dim table because this has only the designation data. Here we have the gender table. This is also a dim table, dimension table. But when it comes to employee table here, I call this as a fact table. Why I call this as a fact table? Very simple. In the entire table, if you find any one column that allows you to do the sum, if you can perform the sum of that column, okay, sum of the column, and the result when you do the sum, if it makes sense, you can call it as a fact table, right? It should make some sense. Why? Because when you look at job ID, there are numbers and you can still do the sum 70, but how does it, it doesn't make any sense, right? Doing a sum of job ID. So understand this, if any column is there, if that allows you to do the sum, yes, then you can consider that entire table as a fact table. So what is it we do, in the data modeling in Power BI, we create relationships like this. We find out the common keys between the tables. So it needs to go to the departments table, okay, this key, and this job ID is there, right? So this one should go to the job table like this. You need to find out the jobs here. Similarly, the gender table. So let's take the gender ID and go to the gender table. So basically, we need to create the relationships in Power BI data modeling. The same concept is called joins in SQL. We write left join, right join, inner join, full outer join, right? Something like that. In Excel, we do lookups. And that's the reason in most of the Excel roles, they ask like, okay, do you know the lookups? The reason being in the real time, the data itself is stored in the normal forms like this. As if you are joining as a data analyst, you should know how to fetch the data from different tables into a single table. That is the reason in Excel, we require lookup formulas. In SQL, we require joins. In Power BI, we require relationships. I hope you got some idea now why the relationships and data modeling plays a major role. Any questions up to this point? Are we good?
Yeah, no questions.
Okay, so here we go. So let's move on to the next one. This is where we need to understand what is a primary key and foreign key. So with that, you will get some idea like, how to build the relationships. Okay. So you see that between, among all these tables, you see a few common things. Can you help me like to find out the common things, among all these tables, this table and these three tables? Yeah, please go ahead. What are the common columns you find in all these tables? Do you see the common columns there between this dimension table and this fact table? Let's go one by one.
The department ID.
Okay, department ID is the one. So I'll just apply some color there just to identify.
Name column also there.
Okay, name column. Which name is it?
Location, gender,
Location. Okay, location. So you're saying this location. Okay, let me just highlight with some other color. And this location you're saying. Okay, fine. We'll come to that. Okay. Gender, someone said. Okay, so go to the gender. This up, pick this up. That's it. That's it. Do we have any other common columns?
job ID,
Job ID.
Was it?
Job
Job.
ID.
Job ID. Okay, perfect. So let's pick up the job ID from here. Hold on. Just use a yellow color there.
department ID. Yeah, done that.
Okay. So department ID is done already. Okay. So you found out the common keys between the tables. Okay. Job ID here, job ID here, department ID here, department ID here, gender here and gender here. The location here and location here, that is not the correct selection, I would say. The reason being, there can't be any relationship with the employee location and the department location. Okay, so this is not a correct one. No. Okay. So from employee table to department table, if you want to create any relationship, you need the ID only, not the location. Because here it is employee location address or employee city. This is the department city. Department also has some location here, right? So do not consider this as a common key or a common column between these two. Okay, so this is not the one. So I'm just taking it off. Right? Location is not the correct one, but the rest of things are correct. Okay, they are the common keys. And we need to find out from these keys, which one is a primary key and which one is a foreign key. Okay, maybe the question for the ones who joined directly Power BI, answer this please. Any idea about primary key? You would have probably heard this, maybe during your graduation days at some point. What is a primary key? Anyone, any idea? That's okay. You don't need to be 100% accurate there, but if you know that. Okay, no problem. So let me explain you what is primary key first. Primary key is always unique and can't be null. Okay. Primary key is always unique and can't be null. Okay, something like this. If I look at the department ID, each and every department ID is unique and you cannot have any null in this table, okay, for the department ID. So what is a primary key? It's always, it needs to satisfy two rules, always unique and not null. Okay. So as you know this, definition now, so tell me, Aadhaar card number, is it a primary key?
Yes.
Okay, because it's always unique and it can't be duplicated with anyone else. Plus, it can't be null, correct?
Correct.
Okay. Let's say your employee ID. If anyone is working, your employee ID, is it a primary key?
Yes, primary.
Yes.
Then, yes, it's a primary key. You're saying, okay, vehicle registration number. Is it a primary key?
Yes, primary.
So you mean to say like the vehicle registration number can't be duplicated?
Yes.
Yeah, that's right. It can't be duplicated. Let's take one more example. PAN.
Unique number.
That's also primary key.
Yes, primary.
Okay, perfect then. So, your answers are okay. I would partially agree with these answers. The reason being, I'll tell you why. Let's take a look at this and try to understand what is a primary key. Okay, take a look at this table. Tell me, every table usually, contains a primary key. So take a look at this table and tell me which one is a primary key in this table. Is it the month? Is it the pay ID, employee ID, salary, or the type of the salary? Which one is the primary key here? So this is the first thing that we need to always look at before building the Power BI models, okay? So tell me,
Pay ID and employee ID is primary keys.
so usually one table comes with only one primary key.
Here two primary keys are there. PID and employee ID.
No,
Unique.
yeah, that's what I'm saying. Like only one primary key is needed. So out of those two, only one is a primary key. Which one is it? Others, which one is it? So once you understand this, then only Power BI looks easy. Okay, MPID. I'll just wait for others' answers also, requesting you to respond in the chat window. Which one you think is a primary key here?
Employee ID.
Employee ID, okay. Employee ID, okay, everyone is saying employee ID. Okay, fine, then others, a few more, please. Let's try to understand from others also. Okay. All right, so most of you are thinking, employee ID is a primary key. Fine then. So what is the behavior of a primary key? Can anyone tell me? Unique
Always
and
unique and null.
not
Not
null.
null.
Okay, perfect. So always unique and not null, right? Perfect then. So that means this must be always unique and can't have any nulls, right? So let's take a look at this. Looks like everything is fine, but here's the catch. Look at this. Which table are we looking at? Employee payroll table, nothing but employee payroll sheet here in Excel, employee payroll. So if you mark this as a primary key, what is the behavior of this? Unique and not null. That means if you have 1, 2, 3, 4 employee ID here, okay, 1, 2, 3, 4 employee ID in this cell. Okay, tell me as per the behavior of this column, nothing but primary key column, because we just mentioned it is the primary key. So 1, 2, 3, 4, can this be repeated in this column once again? Yes, no? In this column, can we repeat this 1, 2, 3, 4 if I mark this as a primary key? Because primary key is the one, it is
No.
always unique and not null is what we discussed, right? So it must be there as unique one and it cannot be duplicated with any other number here. 1, 2, 3, 4, can that be repeated or not? No, no, right? Perfect. So you're looking at the payroll table and we are looking at May 2023 salary. So that means if you scroll down June 2023, once again, we will have to pay this employee, right? Yes or no?
Yes.
Mhm. So next month, by any chance, this employee gets one more new employee ID to get the salary processed by any chance? Every month, the companies change the employee IDs to
No,
process the salaries? No, right?
no.
Okay. So that means understand something that is sounding, kind of a unique one. Don't mark that as a primary key. The reason being, if you look at this table, employee payroll table here, you see 1, 2, 3, 4 is paid here in May, the same employee to be paid in June as well, right? With the same ID, and as well as I've hidden one row here. You see the same employee who got a bonus and the same employee ID, right? So tell me this, if I mark this, of course, in the real time, that is not possible to mark employee ID as a primary key in the payroll table. But what if I mark employee ID as a primary key in this table, in the payroll table? What will happen? What will happen? Can anyone answer this, please? If I mark the employee ID as a primary key in the payroll table, what will happen?
He can't get bonus this time.
What was it?
They can't get bonus this time.
We have to pay only once in a month, once in a year.
Once in a year. Okay, that means in the next year, when I go here to, let's say, June 2024, so that means can I enter that 1, 2, 3, 4 again?
No.
If I mark this as a primary key, you know what will happen there? The entire career, an employee gets the salary
Only once.
in the entire career. Is it fine? Anyone would like to join this kind of a company? On the lighter note, I'm asking. So in the entire career, the salary gets processed only once. Why? Because we mark this as a primary key here. Understand something, if it is sounding unique and not null, don't think it's always a primary key. Yeah. Ravi, if it is like a 10-digit salary is good enough. Okay, maybe yeah, it's like a one-time settlement. Fine then, okay. So here we go. So we cannot mark this as a primary key here. The reason being this needs to be repeated. So then what kind of a key is it? But it is sounding like a primary key only, right? Here we go. You need to consider this as a foreign key. Okay, foreign key. So what is a foreign key? It's a primary key of some other table. Okay, so if you are looking at employee ID here, right, it is a foreign key and it's a primary key of some other table. Which table? Here it is in the employee table. So 1, 2, 3 for Mahesh Hyderabad location. And this is a primary key here. Okay, so don't think always if something is like an ID and don't think it's a primary key, always depends on the table. Remember this very, very, very important before we start building the Power BI models. We need to look at these things only. So when you look at a table, just check the table name first. Okay, if it is an employee table, employee ID is a primary key. But if it is a payroll table, pay ID is a primary key because every pay ID is unique and not null. Okay, now you got some idea why employee ID can't be a primary key here?
Yes.
Yeah, now let's take a look at the bank accounts. Tell me which one is a primary key here. I'll zoom it in a bit.
Account number,
Okay, let's hear it from others also.
Aadhaar card.
Okay,
Aadhaar
Yeah.
number. Aadhaar number.
Aadhaar number.
Aadhaar number. Okay, Aadhaar is the primary key. Okay, so you don't see any duplicates here.
Duplicates are there. Now,
If you want to mark this as a primary key, you know that very well. You can't have duplicates there.
Yeah.
Yeah, so that means it's not a primary key. No. Customer ID maybe?
No.
That also has the duplicates. Account number is a primary key. Yes, account number is a primary key because each and every account that comes with one unique identification number and cannot be duplicated, can't be null. Okay. So let's simple example. If I have one bank account, okay, bank relationship, and in which I have a customer ID C125, and a C125 customer can have a savings bank account, home loan account, car account, credit card account, and all those account numbers are different, but all of them are mapped under one customer ID with the same Aadhaar. But all the account numbers are different. Yes or no? One customer can have multiple relationships with the banks, right? Different
Yeah.
types of accounts we can open under the same customer ID. Yes or no?
Yes.
Yes. So account number is a primary key in this case, not the Aadhaar, not the customer ID. Now you get the point. It always depends on the table you are looking at. If you are looking at the accounts table, account number is a primary key. If you are looking at the payroll table, pay ID is a primary key. If you are looking at employee table, employee ID is a primary key. I hope all of you understood this concept. Yes?
Yes.
Okay. PAN, is it a primary key? The permanent account number, is it a primary key?
Yes.
Are you sure? Permanent account number, is it a primary key? PAN,
Which table?
exactly. You need to ask me a question. Which table? Okay. Which table? You need to ask this question, which table? Because unless you know the table, you cannot say whether it is a primary key or not. Let's say PAN. PAN with the PAN issuing authority. Okay. What kind of a key is it? In the PAN issuing table is there.
Primary key.
It's a primary key. It's a primary key because they issue the PAN for each and every taxpayer, one unique identification number. And in their table, it's definitely unique, right? But the same PAN in the IT returns table,
Foreign key.
why foreign key?
We are filing IT returns every year.
Exactly. Using the same PAN every year, we file the returns. Okay. Student ID. Exactly. Which table? In the student admissions table.
Primary key.
It's a primary key. Perfect. Student admissions table, it's a primary key. But the same student ID in the attendance table, foreign key. Why? Because using the same ID, we'll have to capture the attendance on daily basis. Okay. In the examinations table, student ID in the examinations table.
Foreign key.
Foreign key. Perfect. Why? Because the same student needs to take multiple exams using the same ID. What if I mark student ID as a primary key in the examinations table? What will happen? Exactly. That student can write the exam only once. Okay, because the same ID cannot be duplicated in that table if I mark that as a primary key. Okay. All right. Laptop serial number. Okay, in the production table, laptop production table. Yes, it is a primary key because each and every laptop that gets one unique identification number at the time of production. But the same laptop serial number in the service station table. or a service center table?
Foreign key.
It's a foreign key. Why? Because using the same laptop, serial number multiple times, it can go for the service. Right? I hope you got some idea what is a primary key, foreign key, right? It depends on the table, right? I think now you can easily answer these questions. So tell me, department ID in the departments table, which type of key is it?
Primary.
It's a primary key. Excellent. Designations table job ID is
Primary.
primary. Gender table gender ID is
Primary.
primary. On all these keys in the employee table, they work like
Foreign keys.
foreign keys. Perfect. One final check. A foreign key, can it have any nulls?
No.
Others, can it have nulls?
Yes.
Possible, yes. A foreign key can have nulls. If you look at the department ID, it is null. You get a question, how come a foreign key, can have a null? Simple. Let's say there is an employee joining and we, haven't decided yet, to which department we want to align, okay? Align that person. So we can leave that null. So it's not mandatory that a foreign key must be always not null. No, you can leave that and later you can input a value. While creating this record, you can leave this foreign key, right? And when needed, you can input a value. But if you want to input the value, definitely that value must come from these 5 only. You cannot input 60 here. Okay, integrity constraint. You cannot input 60 here. Why? Because that 60 itself is not there in your department's table. You got the point? If you want to take a value, that value must need to come from the primary key table only. Because there is a primary key foreign key relationship. Got some idea now? So the foreign keys can have nulls, true or false. Foreign keys column can be null, true or false.
True.
True. Primary key column can be null.
False.
False.
False. Yeah. Understood, right? Now you got some idea like how these tables can be joined together using the primary keys and foreign keys. Okay, tell me something. From a single table, we got these multiple fact tables and dimension tables, right? What is this process called?
Normalization.
Data normalization, correct. Okay, one final check. You join as a reporting analyst or a data analyst, okay? Which type of data you like to work the most? Denormalized data or normalized data?
Normalize.
Okay, let us hear it from everyone.
Normalize it.
Okay,
Denormalize.
Denormalized.
okay, denormalized. A few of you are saying, okay. May I know why denormalized you like to work with?
So that
Because the
entire data
data
is available in one
in
table.
one table.
Exactly. If everything is there in one table, it is easy for us to create a report, right? Simple pivot tables, dashboards, slicers, and everything can be done on one table. You get the point. Denormalized data, we all feel like very much comfortable working with, but the reality is all our databases are normalized. So that means we definitely need to work with normalized data. But while doing this, what we try to do, we do a little bit of denormalization on the data. Nothing but if you have so many tables involved, the model performance will be affected. As a result, what we do, as a result, the end user finds it, the report is running little slow. So what is that we try to do? We try to denormalize the data to get that into a star schema. Now, I think you can easily understand the schema design. Now, you know what is a dimension table and a fact table, right? Fact table contains what? Fact table contains what? I told you how to identify something is a fact table.
So we can able to sum the
Okay, simple. Keep it like this. Fact table contains numerical data. Make a note if needed. Fact table contains numerical data and which can be summed up, and the result of that column makes sense. Okay, fact table. Fact table contains what? Numerical data. The result makes some sense if you do the sum. Okay, done. Coming to dimension table, what is the dimension table?
Categorical data.
Correct, categorical data. Something like location details, address details, departments, right? Regions, dealer details, vendor details, employee details, right? All these things are categorical data. You know, you can't do the sum there, right? So fact tables, they contain numerical data. You can do the sum. Dimension tables, they contain categories. Okay. So we try to get the schema design like a star, like this. Okay. A fact table is surrounded by dimension tables. This is what we do in our Power BI data modeling. Okay. And we have the dimension tables and fact tables like this, right? So what kind of data is it? Is it normalized data or denormalized data?
denormalized.
Normalized data.
Correct, normalized data. If you see the normalized data, definitely the keys come into picture, right? Right? Two types of keys we discussed. What are they?
Primary and foreign.
Primary and foreign keys.
Exactly. Now you tell me the very first dimension table that you see here, dealer table, which one could be the primary key here? Can you find out?
Dealer.
Dealer is the table name. Which one could be the primary key here?
Dealer ID.
Dealer ID.
Dealer
Perfect.
ID.
Correct. Branch table is there. Which one could be the primary key here?
Branch ID.
Exactly. Date table is there. Which one is the primary here?
Date ID.
Exactly. And product table, product ID. So you
Product
see
ID.
that the respective tables have the respective IDs as a primary keys. Done. The same primary key, when it goes to, okay, when it goes to this fact table, if you take a look at the branch and revenue table, in the revenue table also you have the branch ID. Then what type of a key is it?
Foreign
Foreign
key.
key.
Perfect. So that means you tell me this, in branch table, branch ID, each branch ID, how many times it will be there?
Only once.
Only once, because you said already it is a primary key, but the same branch, from the same branch, we can have multiple revenue transactions, right? So that means the branch ID, which is a foreign key here, how many times it can be there?
Multiple times.
Multiple times. Perfect. In the data modeling, the relationships cardinality, this is what we are going to talk about. It's a one-to-many cardinality. Here also it is one-to-many, one-to-many, one-to-many. If you want to read it from left to right, you need to read it as many to one. One-to-many, many to one. It just depends on the table positioning. That's it. You're getting the idea now, how the schema models are created in the data modeling?
Yes.
Right. So this is a normalized data, but it's actually, you know, we did a little denormalization on this, but it is still normalized only. Now, let me show you this. What is a snowflake schema? So we also design a snowflake in our Power BI data modeling, okay, to try to understand what is a snowflake. Just take a look at this. You have a fact table that is surrounded by different dimension tables, and these dimension tables have the subdimensional tables. Right? So tell me something. If I want to find out the country-wise total revenue, the country name-wise total revenue, or total revenue by the country name. You know what is it I need to do? What all tables are involved? Can anyone tell me? Revenue and country name. What all tables are involved to get this output?
Country and
Revenue,
dealer table.
dealer and the country.
Right, country table and
Dealer table.
Dealer and revenue.
dealer table and revenue table, correct. 3 tables are actually involved in this process. Why? Because if you want to get the total revenue by the country name, you cannot directly talk to this table. You will have to go via dealer, and from their dealer, you need to go to the country. So if you have more number of, relationships like this, more dimensions and subdimensional tables are involved in one requirement. Tell me, the query processing, will it take more time or less time when more tables are involved in your requirement? Will it take less time or more time?
More.
More time, perfect. Because your query has a requirement, to go to the dealer's table. From there, it needs to go to the country's table. As a result, the query performance will be little slower, right? So that is the reason, sometimes what we do, if there is any small subdimensional table, we try to merge these tables into a main dimension table. A little bit of denormalization, we do that, and so that we can get a star schema like this. You're getting the point now? Why do we do the little bit of denormalization? It is not recommended to completely denormalize the data, as the data will size will be significantly more. So what is it we do? If there are any subdimensional tables with little data in it, we try to merge those tables into a main dimension table, and we can make this as a star schema. Okay, but keeping so many table dependencies is not a great idea for the from the model performance standpoint. Okay, is that clear, everyone?
Yes.
Okay, so what type of schema design is it?
Star schema.
Star schema. What type of schema design is this?
Snowflake schema.
Snowflake schema. Okay, which one we prefer to have in our data model?
Star schema.
Okay, why star schema?
Time will be less.
Okay, so how you can say that time is comparatively less in the star schema?
Denormalized data.
Because we deal with a little bit of denormalized data, as there are no multiple tables involved. Okay, we kept the tables close one to each other, right? So they can talk to them, talk to each other easily, right? The data can flow from one table to the other table easily. Done. So we also discussed a primary key to foreign key relationship. What kind of cardinality is it? The relationship
One to many.
Exactly. One to many. So this one represents which kind of key there? Which key that gets us one there? Key.
Primary key.
Primary key. Many?
Foreign keys.
Foreign key.
That's it. Right. Got some idea, right? So tell me, data normalization, is it a good process? Yes, no?
Good, but not for analysis.
So for the analysts, from the analyst standpoint, we think denormalized data is great for us, but let me tell you one more thing. If we do not do proper data normalization, the table size will be very, very, big. And as a result, publishing data sets onto Power BI service may not be possible. We'll also talk about that. Data normalization is kind of important for the data analysts also. Okay, slowly we'll learn that one. Okay, done. So got some idea, right? Now, what is normalization? What is a primary key? What is a foreign key, and things like that? Yes. Right. So let me show you one thing here. In my computer, I have SQL Server. Okay. The ones who already completed SQL, you have the server installed and it's there with you. So you can see that in your system, but the ones who directly join Power BI, you may or may not have the server. But just in case, if you are working in a company, if you have SQL server there and for that matter, any other server, MySQL server, Oracle server, and if your business agrees you to work with these servers and all, then yes, you can request your IT team to install or grant permission to that server, and one client application also you can get, just in case if your business approves this request. Okay, you can get that installed onto your office machine and you can start practicing it. But as we are working with server, we have a client. Client is SSMS in my case, SQL Server Management Studio. If you are using MySQL Server, then you have a MySQL Workbench as a client application. So different server applications and different client applications are there. Good to have some idea like what is a server, what is a client. Anyways, at the time of working with SQL Server, I'll talk more about it once again. Okay. And you will understand how to read the data directly from a SQL server or a SQL database table. Okay. And then how to create the reports. Yeah. But for now, if you all are good with what is a primary key, what is a foreign key, how the data is stored with these keys, how to identify them, what is a fact table, what is a dimension table, what is data normalization, what is data denormalization, this should be fine. Okay. There are other queries like select queries, using the joins, where clause, having clause, aggregations, and so many different concepts are there in SQL. But yes, once you attend the full SQL course, then you will understand what are those concepts. If you want to directly write a SQL query to get the data, you can also do that. I'll write one SQL query now. Okay, someone who completed SQL, you understand what I'm trying to write. But usually, this is how we need to interact with the database and read the data. Okay, for others, it may look a little new concept for you. Like you may think like, okay, what is that you are trying to do there? Because you are not done with SQL, but try to understand the query, what I'm writing here. That's it. Okay. Select is a keyword that we use for the data retrieval from any table. Currently, I'm interacting with employee database. I have one table called select star from employee table. Okay. So a simple query. I just want to get all the columns from the employee table. What all columns are there? These many columns are there. So one should have SQL skill, because I'll show you why it is needed. Okay. I want to get employee ID, employee name, department ID, department name, and salary. Okay. Then what is it I can do? Select EMP ID. That is my primary key in this table, E name. Okay. DEPT ID. This is the foreign key in this table. D name, which is the name I want to get from the department's table, and the salary of the employee. Okay, from employee table, consider that as E. Let's say do a left join with the DEPT table, consider that as D, and the common key between them is employee department ID is equal to department ID. Just put it as D dot department ID. Okay, done. If I execute this, I'll get these things. Okay. For the ones who are not so familiar with SQL language, you get questions, right? Why did you do like this? Okay, so for this, you need to understand SQL language. But what I'm trying to show you here, this is what we usually do when we want to get the data from a SQL Server table. We directly write a query, and I can use the same query in Power BI with the SQL Server connection. The data is there in SQL Server. The SQL Server name, KK, laptop. This is my SQL Server name. Database is this. Here we have the option. Someone who is good with the queries, they can directly write it and click OK. Now you see, I can easily create visuals using the data that I got from the SQL Server table, I want to create a department-wise total salary report, okay? I want to show the salary and by the department name. See that? So this data, if it gets changed in the database, when we attempt a refresh here, this will be automatically updated. So to perform these kind of things, to write that SQL queries directly to get the required output, okay, we definitely need to learn SQL. Okay, but without this also you can read the data for Power BI. Yes, there is a dependency in terms of understanding the data modeling. Okay, at this point we have only one table, so no issues. But when we have multiple tables here, then we need to understand primary key, foreign key, how the databases are created, normalization, denormalization, all these concepts will come into picture. Okay, but for now, we'll keep it simple. Just first of all, we'll make you understand what is Power BI, how it looks, what is data transformation, what is Power Query, what is mQuery language, right? What kind of steps we can do in order to clean up the data. All these different things we'll discuss. And then we'll move on to the data modeling. And then once again, we'll talk about the SQL concepts to understand primary key, foreign key relationships, how it comes, right? And different things are there, right? Is everyone okay up to this point? Done. So far, is it fine? Like everyone is able to follow, especially those primary key, foreign key concepts? Someone who completed SQL, I understand like you are quite comfortable with this concept, but someone who joined in Power BI sessions, you are okay, right? So please let me know so that, if there is any doubt or confusion, I can give a different example. But if you are finding it comfortable in the same way, I'll proceed in the same way. Okay, thanks for that then. So what is data analysis and why it is important? We'll do a quick, data analysis using Excel only because most of you are coming from Excel background. Okay, why the analysis is needed? Okay, so what types of analytics? I'll come to this, but I would like to show you why data analysis is needed, and as part of the data analysis process, why do we need to prefer data visualization? Okay, I'll do one thing. Probably the ones who know the answer, don't answer this, please. I have some data here. Okay, so I have all the data in one place. So tell me if all the data is in one place, not in multiple places. Okay, what kind of data is it?
Denormalized.
Yes, it's denormalized data. Right. So I have the region column here and I have the profit column here. As you know that, the required columns are here. If I want to get total profit by region, okay, total profit by region, how do we do this? You are coming from Excel background, you know the answer. How do we do this? Total profit by region, if I want to see, what is it we do?
We look up with region column.
No, region is already there.
Pivot table you can do it.
Pivot table.
Correct. Let's create a pivot. Right, we have profit. And what is the other thing that we need to use? Region, right? Region name is here. Okay, that's it. Our table is ready. Okay, from this data, if you look at only the raw data, you don't know exactly what's happening. But when you visualize or when you create a summary of this data, you can easily find out what's happening there. Okay, so this is all good, but business has a question. Okay, I'll ask this question and I'll give you 5 seconds only. Okay, the question is this: you have so much of data and you summarized it, and the business asked you, okay, I'll give you only 5 seconds. Huh? Which region has the least profit? Time started. 1, 2, 3, 4, 5. Okay, which region has the least profit?
Central.
Central has the least profit. Okay, others?
South.
Okay, someone says south. Okay. Someone says north. Okay. Okay, I'll give you one more time. 2 seconds. Take a look at this and tell me the answer. 1, 2. Which one has the least profit?
South.
Central? North? Okay. Someone says south. You know why this is creating a lot of confusion, you know? Because you are trying to analyze the data with the help of a table. You're trying to find out which one has the least, okay? I'll do one thing. I'll just do a small modification there, an addition there. Just keep the cursor on the pivot table. I'll insert a pivot chart, and this time I'll give you only 2 seconds time. 1, 2. Which one?
South.
South.
Now you understand the importance of the data visualization. So the same numbers, but only one thing is that when our mind is trying to process which one is the least here, you need to look at the decimal points and what is the value here, and you need to read all of them. But when you turn this into a visual, it's easy for the end user to understand the data quickly and quickly take the right decision. Okay. Power BI is all about that. We have different types of visuals there, very, very powerful visuals. Okay, the moment you look at it, you can easily find out what's happening in the business. And along with that, you can also get additional visuals, very, very customized visuals. Okay, all these different types of visuals are possible in Power BI, right? So we'll take you through this presentation step by step. And tomorrow we'll also discuss once again the fundamentals of SQL. And then tomorrow we need to install Power BI. What is Power BI? What kind of things are there inside the Power BI? What is the role of these 4 things? Power Query, Power Pivot, Power View, and Power BI Publish. Okay. And the different components of Power BI, right? What is the data gateway? How to install Power BI desktop and things like that. These all things we'll discuss tomorrow, right? So SQL concepts, all of you are okay so far? Primary key, foreign key, what is one to many, many to one, how these keys can play their role in the data modeling. Snowflake schema, star schema. Everyone is able to follow? Right, just in case if you are stuck, if you have any question, feel free to stop me, ask me questions. I'm here to help you out, okay? So yeah, that's all for today. And I hope all of you got access to the material package and the videos. Please start practicing it. Today, we discussed only a few basics. Even if you don't do much practice, that's fine. But going forward, once we're done with one important topic, I'll give you a homework and you need to complete that. Done? All right. So I'll see you all tomorrow, and please make sure you just download the material and be ready, because tomorrow is we are going to download Power BI Desktop and we want to try out a couple of reports. Okay, cool then. So thanks everyone for attending today, and I'll see you all tomorrow.
Thank you.
Yep, thank you. Bye.
Thank you.